Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 3 of a unit motion in a plane. So let's begin with today's class. This is part 3 of the vectors and today we are going to start our discussion with the subtraction of vectors. In the last class we were discussing about the addition of vectors. Basically it's an methodology to find out the resulting vectors, and today let's begin with the subtraction of vectors. Basically subtraction of vector means it is a subtracting of one vector from another is equivalent to the adding the negative vector to the first vector. I hope you remember this, that suppose I want to perform p minus q, then I am supposed to do this as a vector of p plus vector of minus q. Yes, so let's say this is my first vector, vector p, this is my second vector, vector q, and if I need to perform a p minus q, then what I need to do is I need to just convert this plus q into a minus q. Now how it could be converted? How it could be converted? If I just simply the reverse the direction, if I just simply the reverse the direction, then this q can be converted easily to a minus q. So the situation would be that suppose this was the p, this was the q. Now if I want that it should be a p minus of q, then if initially it was the direction, now the direction would be reverse and minus q would be in this direction. So this is p, this is minus of q, and I need to find out an angle between this two. So this would be is equals to resulting of this is p minus q. I hope this is clear to you. Is it is it clear to you? Are you sure? Okay. So magnitude of p minus q, it is s is equals to mode of p minus q is equals to under root of p square plus q square minus 2pq cos theta. Yes, and angle, and its angle with x axis, it's tan alpha is equals to q sine. Here previously when it was a methodology of addition to vectors, it's a 180, it's a theta. Here it is a 180 minus theta, and this is p plus q cos 180 minus theta. So if I solve this, it's a q sine theta, tan alpha is equals to q sine theta upon p minus q cos theta. Yes, yes, I hope you understand this. Yes, shall I add something? Shall I? If magnitude of p equals magnitude of q, that means two vectors are equal, then their resulting vector's magnitude will be 2 into p into sine theta by 2. Please remember this. And alpha is equals to theta by 2, it is the same. Alpha is equals to theta by 2. Is it clear? Yes, is it? So shall we perform certain numericals based on this? Shall we? Let's move ahead and doing the questions. Have your pen and paper and do this, please. Yes, suppose a p is there vector p is there, having a force of 4 newton. Vector q is there having a force of, let's say, 1 newton, and this two have been assigned, two have been angle of 120 degree between them. So the situation would be something like this. Let's say this is 4 newton, this is 1 newton, and angle between this two is 120 degree. Now you need to perform p minus of q. How it could be done? If you want to find out the p minus of q, how it could be done? How it could be done? Then what I know is that p minus q, it is the simply p plus minus of q. I hope you understand this. This is just an addition of p and the negative of q. How negative of q can be developed? that this is 1 Newton and this is the Q. So if I reverse the direction of this, that means in this direction this is minus of Q, it must be having a same magnitude because it has been multiplied by minus 1, because it has been multiplied by minus 1. So this is minus of Q. And now the angle between this two, the angle between this two is, this is 120, so this must be in 60 degree. Now if I want to find out the resulting vector's magnitude, then this should be is equals to R equals to root of P square plus Q square minus of 2PQ cos theta. Then that should be is equals to P square, it's a 16, plus Q square, it's a 1, minus of 2 into 4 into 1 into cos 60. Cos 60 is 1 by 2, it's a 1 divided by 2. So this 2 has been gone, and the term remain is, this is root of 16 plus 1, 17, minus of 4. So this would be a root of 13 Newton. I hope this is clear. Is it clear? Yes. Is it? Is it clear? Are you sure with this? Can it be done? Can it? Yes. Great. So let's move to the next. Do you remember the unit vectors? Do you remember the unit vectors? Yes. Do you remember that how unit vector in x direction can be presented? Do you? So let's have a look of that. Then suppose this vector p is there, and vector p has been given as 4 I cap. Now what is it? I cap. Yes, it represents that unit vector in x direction. This is the unit vector in x direction. One of the vector q, it's a, let's suppose 2 I cap, it's a unit vector in x direction. This x I represents, or I cap represents the unit vector. That means a vector having magnitude of 4, but it is in x direction. And if I need to perform R, if I need to perform R is equals to P minus Q, how could I do this? So what I understood is that this is first vector, this is 4 I cap, this is vector P, and this is vector Q having magnitude of 2 I cap. I need to perform subtraction of this. So my situation would be look like this. It's a first vector 4 I cap, this is 2I, so this is minus of 2 into I. Yes, this, look at this, this is in positive x direction, so I have just reversed the direction. Now this is minus of q and this is plus q. What can you do? You can simply understand that this is in positive x direction, this is in negative x direction, so the remaining term would be equals to in positive x direction, and this is the magnitude of the resulting vector. R is equals to P minus Q. So is it clear? Is it clear? Yes. Can we do one more? Can we? Let's have a look. And somehow a little critical. Suppose they have given that vector A is 2I cap plus 3j cap. What does it mean? What does it mean? Please think in your mind, and while I have a data with me. And vector B is equals to 4I plus 2j. What they want is that find C is equals to 2A minus of 3B. Yes, this is what they require. Now you must know that I cap represents unit vector in x direction. J cap represents unit vector in y direction. It may be having an k cap. Here it is a two-dimensional only because it covers x and y only. It could be a three-dimensional. It's a unit vector in z direction. I hope these things are clear. Yes. So let's begin that what I need 2 into a minus of 3b. So first I must have this a is equals to 2i plus 3j, and I need to convert this to a 2a. When I multiply with any number, when I multiply with the any positive number, at that point of time my direction remains the same, my magnitude will be multiplied, so it should look something like this. It's a 2i plus 3j multiplied by 2, so this is 2 into 2, it's a 4, but direction remains the same, so it is a I cap. 2 into 3, it's a plus 3 into 2 into 3, it's a 6 into j, so it is something like this. It's in 4i, it's in 4i plus 6j. Yes. Now what is your b? The b will be, it is a 4i cap plus 2j cap, so a 3b will be that this is 3 multiplied by 4i plus 2j, so that would be equals to 3 4s are 12i plus 3 2s are 6j. I hope this is clear. Yes, this is 3b. Now what I need that c should be is equals to 2a minus of 3b. It's a minus of 3b, so actually it is 2 of a plus minus of 3b vector. Is it clear? So what I need to do is I need to just multiply this with the minus 1. So this is, if I want that it's a minus of 3b, then it would be a minus of 1 multiplied by 3 of b. So if I multiply any number with negative of the number, if I multiply any number with the negative of number, the direction will be reversed. So if it is representing in positive x direction, now it will represent itself in negative x direction. Same is true for the y and z as well. So if this is the case, then this should be equals to minus of 12i minus of 6j. Yes. So this is 2a. 2a would be equals to 4i plus 6j minus of, or plus of, minus 12i minus 6j. This minus is this 6j would be gone, and the remaining term, this is 4i minus 12i, this is minus of 8i. So this would be the final answer. What was yours? It is the same. It is the same. So shall we do one more question like this? You feel comfortable with this? Yes, are you comfortable with this? Yes, can it be done? So if after this you must be able to perform addition as well as subtraction. Yes. So let's check it out. The question says that vector a, it is a 2i plus 4j minus of 3k. Vector of b, it is the 4i plus 2j plus 4k. It's a 4. And let's say that c required 2a minus of 3b. So first you need to perform 2 into a. This a should be equals to 2i plus 4j minus of 3k, and minus of 3 into b, that means minus of 3 into 4i plus 2j plus 4 into k. Yes. So this is 2 into 2, it's a 4i. This is 2 into 4, it's an 8j. This is 2 into 3, it's a minus of 6k. Minus 3 into 4, it's a minus of 12i. Minus 3 plus 2, it's a plus 6j. Minus 3 plus 4, it's a minus of 12k. Yes. Now you understand this, that this is 4i, this is minus 12i. Even if you look this on a graphical basis, then you must understood that this is 4 and this is minus 12, and these two are in the x and negative of x, so I need to subtract them. A same thing is true for the 8j. Let's suppose this is the 8j and this is even 6j, as these two are in the same direction, as these two are in the same direction, direction of y, then that's they must be added, something like this. So I hope you understand that I need to perform a mathematical calculation with I, with the I, j with the j, and k with the k. Yes, now you know the reason as well that why we are doing so. Yes, so if I do this, it's a 4i minus 12i, that would be equals to minus of 8i plus 8j plus 16j, this is plus 14 of j, minus 6k minus 12k, it's a minus of 18k. Yes, and this is it. This is done. Yes, did you get the same answer? Do you? Yes. So now are you clear with this? Are you? So shall we move to the next concept of a vector? Are you sure? Are you? Let's move on. So now we are going to discuss about the resolution of vectors, and let's look at how we resolve any vector, how we resolve it. So basically we are going to resolve any vectors into their rectangular components. These are said as the rectangular components. Now what is it? The rectangular components means that any of the vector is there, we are going to split that vectors into two or more components, such that the combined effect of this component is same as the original vector. That means if I am going to combine this vectors, then the resultant of this vectors would be having the same magnitude as that of the original vector. So let's look at this, that this is Cartesian system, and this is x-axis, this is y-axis, and I am having in one of the vector, that vector having a magnitude of r, and it is at an angle of theta, with the x-axis. Yes, so if it is having an angle of theta with the x-axis, what I can have is that this can be divided into two segments, one in the x-axis, one in the y-axis. When we divide into rectangular components, we generally divide any vector into the x-axis or onto the y-axis, and if required on the z-axis, but generally we are going to do this two only, yes, in the x and y. So we divide that into the rectangular components, and what I can have is that vector I must be equals to rx I cap. Yes, I have written this is as an I cap, this is as the j cap. I cap represents, what does it represent? Yes, I cap represents the vector in a direction of x, or j cap, it's a unit vector in the direction of y. I hope this is clear. Is it clear up till now? Yes. So this was the situation. If you look at this triangle, that is the, let's look at the triangle O, it is 90-degree OAC. Then if it is RY, this is R of Y as well. So if you are observing this triangle and you find out the cos theta, then cos theta would be equals to Rx by R. So what I can have is Rx is equals to R cos theta. Same way, if you find out the sine theta in this triangle, then sine theta would be equals to Ry by R. Yes, it is the opposite side divided by hypotenuse. Yes, so this is sine theta. Sine theta is equals to Ry by R, and that Ry, that R of y can be represented as R sine theta. So look at this very carefully, that split up I have split up my this vector R into two rectangular components. One of them is the Rx, another one is the Ry, and value of an Rx would be equals to R cos theta, and value of an Ry would be equals to R sine theta. And as this Rx and Ry are perpendicular to each other, look at this. So when I solve this, or I find it out, the resulting vector of this, it would be the R. That is what my requirement is, that R is equals to under root of Rx square plus Ry square. I hope these things are clear to you. Is it? Is it clear? So this is the thing, that Rx is equals to R cos theta, Ry is equals to R sin theta, and if I want to find out the angle, then you must know that this is ry, this was the angle theta, and tan theta is equals to ry divided by rx. So this theta is equals to tan inverse of ry by rx. Is it clear? Is it? Can it be done by you? Can it? Yes. Similarly, if it is the case of three dimensions, then my vector r is equals to rxi plus ryj plus rzk. Then the resulting vector can be considered or can be calculated as r is equals to root of rx square plus ry square plus rz square. Is it clear? Is it? So shall we practice the same? Shall we? Let's begin then. Or before the practice, I want to conclude something. Please look at this very carefully. This will help us to make sine and cos. That let's say one of the block is given, and on this block a certain force is acting in this direction. So if I want, and this is this is at angle theta with the horizontal axis. So if I want to divide this, or if I want to break this force F into two rectangular components, they are the cos theta and sin theta. Yes. So let's say this is the x axis and this is the y axis. So what I know is that if I make a triangle over here, this must be y. Yes, this must be a y. So this is F, this would be the, I can say, fx, and this would be the f of y. So if I write like this, it's a cos of theta, this is equals to fx by f. So this fx is equals to f cos theta. Same way sin theta, it is equals to fy by f. So this fy is equals to f sin theta. Yes, I hope you understand this. Yes, but a very good assumption is, a very good look into the matter is that this x, that this makes an component of cos and this makes a component of sine. So how could I determine, because every time it is not possible for me to make a triangle and write down the value of cos theta and then write down the value of sine theta. So what I can conclude is that we are having cosine component with the direction with which we are making an angle. Do you understand this? That this says that we are having an cosine component, we must be having an cosine component with the directions with which we are making an angle. So here I am making an angle of this cos theta with the x-axis, so I must have fx is equals to f cos theta. Yes, once I find out the cosine component, once this has been done, once I have done this, then I must know that sine component will be perpendicular to cosine component. Yes, sine component must be perpendicular to the cosine component. So once this is fx, this must be the fy, and this two are perpendicular to each other. I hope this is clear. Is it? Is it? Is it? So please remember, this is the summary sheet of resolution of vectors, and now we are going to do the practice on this. So let's begin then. Suppose one of the point is there, here the velocity is v, and now this is the y axis, and here it is making an angle theta. Now we want that, find out rectangular components of vector v. So what I know is that if this is making an angle theta with this, with y axis, what I say, then this must be the v cos theta. I hope you understand this. If this is v cos theta, if this is v cos theta, because we learn it in previous slide only, that when it makes an angle with this side, it will make cos component for us. So we always remember that where angle would be there, when and where angle would be there, it will make cos theta component for us. And once you have find out the cos theta, once you have done with the cos theta, you must know that vector perpendicular to this component, it is this, it would be the v sin theta. So we have split it up into the v cos theta and v sin theta. If you want to write down the v, then you can write it that it is in x direction, then it's a v sin theta I cap plus v cos theta j cap. I hope this is clear. Is it? One more? Are you interested in one more? Let's have a look then. The question says that, suppose this is the wall, one ball is there, is moving in this direction with velocity v. This is the horizontal and this is the theta. So find out the rectangular component. The question remains the same. Find out the rectangular component of the same. So what I know is that it is making an theta with the x-axis. It is making an angle theta with the x-axis. So my v cos theta would be in this direction. My v cos theta would be in this direction. Now I have find out the v cos theta. I have find out the v cos theta. Now where would be the v sin theta? It must be perpendicular to this. It must be perpendicular to this, and the perpendicular to this, that means this is would be the vector. This is v sin theta component, and that's it. You did your part. Yes, one more observation is these are the certain tips and tricks, or we can say these are the lock and key, so that we can understand that my answer is correct or not. That, look at this v is, that object is moving inside the, this object is moving inside the wall, towards the wall. Then my components v cos theta as well as v sin theta are also moving in the inside direction. I hope you understand. No? If no, then let's look. You might feel this. Let's suppose this is the wall, and after moving on this, it is moving in this direction, and it is making an angle theta in this direction, moving with the same velocity. Now make a v cos theta and v sin theta of this. Now make a v cos theta and v sin theta of this. So let's first find out the v cos theta, as it is making an angle theta with this. So this would be the v cos theta, and component which is perpendicular to this, it would be a v sin theta. So what would be the situation? Look at this. Now you can compare this to, it's a first, it's a second. If in this diagram object is moving towards the wall and something like inside the wall, then this v cos theta and v sin theta always there to protect it. Look at this, these two vectors are protecting this vector. I hope this is clear. And if this is the situation where v is moving outside, then their components also, their components, that means I'm talking about the v cos theta and v sin theta, they are also moving in the outside direction. This is something like this. I hope this is clear. Is it? Is it clear? Is it clear? Can we do this? Are you sure? Are you? Yes. Shall we take a very interesting question of this? Shall we? Okay, great. This is one of my favorite. That, let's say, actually this is the question of the NLM. It's a Newton's laws of motion, but we are going to use the same concept. It's a concept of resolution of vectors. So let me try this. this is wedge, this is angle theta, and I have put a weight m, or block has been put and its mass is m. So what I need to do is, you first I need to make that what are the forces that is acting on this block. If you know this, it is well done. If you don't know this, that what are the forces are acting, let me show you that one of the force would be there, that is the mg, and that is acts in this perpendicular direction and towards the earth. This is mg. One more force would be there, one more force would be there, which is the normal force, which acts due to contact between two surfaces, and which acts perpendicular to this. It's this kind of force. This is the normal force. Now I need to make cos theta and sin theta component of first of the mg, and then would be the then I would be interested in normal. And if you agree, then we will go beyond this. Yes. So first let's perform this task. If you understand, this is theta, this would be the 90 degree. Yes, because it acts perpendicular. And this is, what is it, this would be the 90 minus of theta. I hope you can see this. Yes. Now if this is 90 minus theta, and if I make a straight line, look at this, this is perpendicular, this is perpendicular to the surface. Here I have used 90 minus theta, so what is it, this is the angle theta. So what I can understood is that this line, or with this line, mg makes an angle theta, and with which we are making an angle theta, we make a cos component of it. It's an mg cos theta. I hope you remember this and understood this. If this is mg cos theta, then this must be mg sin theta. Yes. Yes. Do you understand up till this? Do you understand mg cos theta, mg sin theta both? Do you? Yes. So let's move to the next task. I need to divide, or I need to segregate this normal force into two components, into their cos and sin. So if you understood this, can I make this straight line something like this? If this is theta, this must be theta. If this is theta, this must be theta. So what I can assume is this n makes an angle theta with this line. So this will make a cos component of this. It's an n cos theta, and this component will be the n sin theta. Yes. So this things have been done. So you understand this? You understand? So can it be done by you guys? Can it be done by you guys, that how we can segregate our cos and sine, and how we can divide any of the vectors into its rectangular components? Can it be done? Are you sure? Okay, let's move to the next questions. What they say it is that unit vector of a is equals to 1i plus 2j plus 3k. This is the vector a, and I need to find out the unit vector of this. So I must remember that my unit vector would be vector itself divided by its magnitude. So my first task would be to find out the magnitude. How could I get it? So as it is in three dimensions, let's say I cap plus j cap plus k cap, then I must know that this a was, if you remember that this is vector a, then it would be an axi plus ayj plus azk. Then this mode of a would be equals to root of ax square plus root of ay square plus az square. This is under root of ax square plus ay square plus az square. Yes. So here it's a 1 square plus 2 square plus 3 square. So this will be a root of 14. This will be a root of 14. So this my vector a, or it's an unit vector of a, would be equals to vector itself divided by root of 14. Yes. You can write like this, it's a 1 I cap divide by root of 14 plus 2 by root of 14 into j cap plus 3 root of 14 k cap. This is unit vector of a. This is unit vector of a. Yes, this would be the answer. Got it? Can it be done? Can it be done by you guys? Will it be? Are you sure? Great. Let's move to the next. What they ask is the magnitude of vector p is equals to x of vector p is equals to x of I cap plus y of j cap plus z of k cap is. Okay, so this is x, y, and z. So this r is equals to root of rx square plus ry square plus rz square. My rx, in this case, my rx is r, my ry is y, and my r of z is equals to k. So this is equals to root of x square plus y square plus z square. That's it. Done. Done. Are you sure? Let's move to the next. What they have given me, that magnitude of vector a, 1 I cap plus 2 j cap plus 3 k cap is, yes, under root of x square plus y square plus z square. It's a 1 plus 1 square plus 2 square plus 3 square. So this is root of 14, and this that you understand. Yes. Yes. So now, are you comfortable with the subtraction of vectors and resolution of vectors? Are you done with this? Are you? Yes. So can it be done by you guys? Can it be? Can it be done by you guys? Yes. So now let's wind it up this lecture over here only. And in the next session, we are going to done with the multiplication of the vectors. We are going to done with the multiplication of the vectors and some other topics. They are the Lemis theorem is there, and angle of cosines would be there. Yes, but before you tune to that lecture, please ensure that you must be comfortable with from very beginning part. It's a part 1 of the vector to the part 3 of the vector. Each and every concept must be clear. Yes, please practice a lot. Practice will save us. Thank you. Have a good day. Take care. Bye bye.